Hi students, MCQ number 11. Two spheres of the same material have radii 1 meter and 4 meter and temperatures 4000 K and 2000 K respectively. Then the ratio of energy radiated per second, okay, by the first sphere as compared to that by the second sphere has to be determined. Once again, this sum is also based on Stephen's law of radiation. Now, first of all, what are the given informations we will write? The radius of the first sphere is equal to 1 meter and that of the second sphere R2 is equal to 4 meter. Okay, the radii are given. Then the temperature, surface temperature of the first sphere is equal to 4000 K. And the temperature of the second surface is 2000 K. Okay. Now the total energy radiated per unit area per second means into 1 second. T is equal to 1 second. So this is equal to sigma into T1 to the power of 4. So E1 is equal to A1 into sigma into T1 power 4. Similarly, E2 must be equal to what? E2 must be equal to area A2 into sigma into T2 to the power of 4. Now I will take the ratio. So E1 by E2 ratio is equal to A1 sigma T1 power 4 divided by A2 sigma T2 power 4. So sigma get cancelled and therefore E1 by E2 must be equal to the ratio of the areas, that is 4 pi R1 square divided by 4 pi R2 square multiplied by T1 by T2 whole power 4. So 4 pi get cancelled. This is R1 by R2 the whole square. R1 is 1 and R2 is 4. So this is 1 by 4 the whole square into T1 by T2, 4000 by 2000. So this is 4000 divided by 2000, the whole power 4 it is. So now these three zeros get cancelled. So 4 by 2 is 2. So this is 1 by 4 the whole square into 4 by 2 is 2. So 2 power 4. Therefore, E1 by E2 is now equal to 1 by 16. 1 by 4 whole square is what? 1 by 16 into 2 power 4 is also what? 16. So this is 16. So this is equal to 1 is to 1. Therefore, E1 is to E2 ratio must be equal to what? 1 is to 1. This is the correct answer. Let us see. Option A itself is the correct answer. Therefore, option A is the correct answer. Okay, I hope you must have understood well. Fine.